This is kind of like a little bit of an update since the PLC project was transferred to a round-the-wall layout. Since then, I wanted to explore the possibility of when I originally designed the second generation project, the intention was, as you've seen here, that what is I call the team track was supposed to be a Y track, and with this would allow the trains to run in either direction by decoupling the cars on the throughway east here, and then allowing the locomotive to back into the Y, turn around, come out of the switches, back up, recouple with the cars, and travel in the opposite direction. But when I decided to transfer the project to around my wall to basically give it a permanent home, to build this was really impossible since it is a ceiling mount system. So after I'd done it, I just since I'd already had the switches, I was like, could it have been possible to do what I was originally thinking of doing? So I did kind of build this and just some real simple controls with another Lionel transformer and 5 switches. But also, in the meantime, I was also continuing some learning in PLC projects, and I was lucky enough to obtain this Micrologix 1400 on eBay, used, but in good condition. Sometimes it's like when I'm not in a hurry for anything, I just kind of, just keep an eye out on eBay, and sometimes a really good deal comes up, and bam, I grab it. So I was able to obtain this extra one as a spare and for more experimentation. But also, too, I purchased this from Automation Direct. This is a Click PLC, and at work I've used this in several projects. It's a low-cost PLC. It does have a more limited instruction set, but for a lot of small projects, this little guy actually works really good. And this also has communication capability called MODBUS, and I was foreseeing that in my job I was going to have to maybe utilize that capability of being communicating on MODBUS protocol to remote devices. So I picked up this inexpensive Waveshare relay board, which just gives you 8 relays, single pole, double throw, that by sending commands over to the serial port, which, it is RS-485, not RS-232, you can actually turn these relays off and on remotely, which also saves on inputs and outputs. Like, even though like these outputs say on the Click and even on the Micrologix are relay output, these are single throw, single pole, unlike these, which are single pole, double throw. So that opens up some other possibilities. And also, too, like, just for an experiment, this is a temperature humidity module. It just simply reads temperature and humidity and transmits it back to the PLC on serial communication. Well, so since I always tend to not ever stop thinking about things, I had thought, well, could these Modbus modules have been applied to the PLC project? So I ended up building this as a test. Basically, I purchased more of these Modbus modules, which actually these are relatively inexpensive on Amazon or eBay. They only cost about $35, which is actually cheap in comparison to if you need point I/O on a PLC. On a Click PLC, you're looking at about $50, $60. Now, on a Micrologix, you're talking several $100s. So it's actually a considerable price difference. And honestly, for something like the PLC project, speed of changing of the I/O isn't really that critical. I mean, we're talking milliseconds. And, because obviously point I/O on a PLC could react much quicker than serial communication on a remote module. But for the purposes of, say, a train project, it really doesn't matter. So then, also, this module is a 32 input, which can read 32 points of input. In this case, this one's a PMP input, which means a sourcing 24-volt input. In actuality, I probably should have gotten the other type, the NPN, but oh well. And so I decided to build this, which will allow throwing remote switches and controlling the track power, and then utilizing these little modules, which I'd purchased originally for the PLC project but didn't need. This picks off the remote switch's green and red LED light, which tells it the switch is either in the throughway or the turnout position, and feeds that back to the switch, or feeds it back to this module, which it's a 4.5 volt signal, so it has to be converted to 24 volts, which is what these boards do. These top two ones aren't shown, or look like they're dead. They're not really dead. I built this with the idea of 7 switches, and I only have 3 hooked up just for testing. They're double stacked, so that's why, the ones underneath are the ones connected. So when, they're thrown, you'll see them change. The only thing is the Waveshare modules have an input of 5 volts. So what this here is this is a DC to DC converter, which just takes the 24 volt input and changes it to 5 volts to supply the power to the Waveshares. So the idea is that this could be remote to the PLC project, and the only thing you would need to that would go back to the PLC would be, well, you have your 24 volts for power, and then just simply this 2-wire serial communication cable. All this could be located somewhere else. I've also did add the ability for block detection, and I ended up having to use a OS 16 module because I needed, again, PMP input. So I actually had this reversed, and the block detects, are common ground, or NPN. So this actually not only picks the signal up and provides isolation, in case of a derailment where track power could potentially get fed back into the outer rail, which would damage an input. This provides isolation back to the input module. What this could potentially mean is it could modify the PLC project, and basically this entire bank of relays can be eliminated. This controls all the track power. These control the remote switches. And again, these switches are single pole double throw, which also provides interlock isolation on the switch throw, because the point IO is only single pole single throw. And these modules would also be eliminated too. And these are actually quite expensive, especially nowadays. So, that could eliminate all of this. And these here are for the signals on the layout. And with just getting another one of these modules, basically this entire bank of relays could be eliminated. And also what it could also potentially mean is on the engineer control panel, all of these relays could be eliminated, which is the automatic manual control. The one nice thing about the Waveshare module is the relays are rated for 10 amps capability, where the point IO on the modules on the PLC, whether it be the click or the micrologics, is only rated around 2. Like I said, these control the track power. So, and these are high current relays. I would not even need them anymore because the Waveshare module could handle the current output. This could significantly reduce the amount of cabling and the footprint of the engineer control panel and potentially the PLC project. This just gives a little quick demonstration, or this is just a screenshot of sending a MODBUS command to the Waveshare relay using a free program called QModBus Master, which was great for experimentation. That it just, tell it that I want to write multiple coils, which in this case are the relays. Then the first line is what's transmitted out to the Waveshare, and then the Waveshare responds back, and that tells you whether it was successful or if there was an error. And in this case, it says the values were written correctly, and then these relays that were toggled as a 1 would close. So of course I had to play around and write a few test programs. So what I did was design just a quick screen and on a program that I could toggle switches. Say if I want to throw all 3 switches at once. Well, I only have 3 hooked up. And then you would see when you would trigger it, success. And it'll show you the Waveshare relay. Now, I don't have any block detection capability set up on this little test layout, so what I did was just run a couple jumpers to the DC common just to bring up 3, just to close 3 block detects, which are reflected here on this bus. This here is showing the switch position. So like if I manually toggle the switch, you'd see the lights change on the various inputs of this module, which is then transmitted back to the PLC. And with some HMI programming, I could also bring it up in a more descriptive way. As the switches are thrown, it can be shown whether it be to the throughway or the turnout. And also too, I put up little indicators for the 3 block detects that are currently closed manually. This would also give control of the track power capability just by simply toggling. As soon as the switch's position changes, as soon as I tell it to toggle one of the switches, you'll see it being reflected that track power came on, 1 and 8. And just like if I turn them off, they go off. Now, I did design the switch throw as in the way I originally designed the project, whereas the last relay would close the track common, which would provide the common to the other 7 relays, and then depending on where those switches are placed, then that would actually throw the switch. During the process of developing the PLC project, I was finding the switches were throwing by themselves as the train was traveling around the track. This was at a time when I tried to modify the switches to actually try to detect the train on the switch, which ended up being a failure, and I was causing floating grounds on the switch, which was messing them up. So then I ended up undoing it, but then I'd modified the switch throws where, as you'll see in the other video, like in a couple back, that I ended up having to modify it so each relay would only close one side, whether the channel 1 would be, switch 1 throughway, channel 2 would be switch 1 turnout. If necessary, if I do find that this does not work or still causes interference, I just wire this the same as the way I did, which is now the PLC project. The only difference is this Waveshare would be reduced from controlling 7 switches down to 4, which for the PLC project around my wall, it's all I need. But when I was originally designing the project with the wide track, I needed 7, and I had to do it with only 8 outputs, just by given the costs of the point outputs on the micrologics. This just simply shows the those interface boards that picks off the remote switches LED position and then converts the signal to 24 volts sent into the input module. It's basically similar to the origin board that's on my PLC project that does the same thing. And this is that Amon board that provides isolation to the block detections back to the input module in the event of a derailment that could potentially cause track power to be fed back. This would isolate it so that it would protect the digital inputs from any potential damage. As I explained in one of the other videos way back, if anything, it would blow one of these out, which you just pull it out and replace it, and you're good to go, rather than blowing one of these inputs out, and of course, you're not really going to be able to repair that. And one thing I ended up stumbling across recently was I didn't realize they made a 32-point channel relay module, Waveshare. Basically the same 10 amp relay capability, single pole, double throw, in one package, and that would actually take the place of 4 of these. So one of these modules would actually be capable of doing everything on the PLC project, the train project, including the signals. Interesting. And it also turns out that this 32 point input module can also be purchased as a syncing input, NPN in this case, versus PNP. And as you can see by the price, it's certainly a lot cheaper than any point IO on a PLC. So this is just kind of like a little, I don't know, update of what I've been up to ever since the PLC project went around the wall. Just kind of exploring some theories. And as I always say, it never hurts to stop learning new things. Now, will this go any further? Who knows? Depends on how how many more ideas I get. But for now, take care.